So the next question is design a sequential circuit to convert BCD to XS3 code. Okay. So in order to design a sequential circuit, we have to go through different steps. So the first step is you have to write down the input and the output table. So in this case, what is your input? Input is your BCD and output is your XS3 code. So how will you write the input and output? Input 0 to 9 and output will be, you are going to add 3 to the BCD. So you will be getting the output table. Okay. So you are assuming that your lowest significant bit, that is your LSB, is your first bit. Now second step, you have to draw the state graph. Third step, state table. Step 4, reduced state table. Step 5, assignment map. Step 6, transition table. Finally, you are going to do the K-map simplification, and which will pave the way for your circuit diagram with your flip-flop. Okay. So moving on to the first step, you are going to write down the input. I'm taking it as X input BCD and Z is your output, XS3 code. So you are taking it, it is 4 variables, right? So T0, T1, T2, T3 at 4 instant of time. So 0, 0, so you are getting BCD 0 to 9 and you are going to add 3 to the input so that you will be getting the corresponding output. For example, 0, 0, 0, 0. BCD 0, when you add 3, it is 3, right? 0, 0, 1, 1. Similarly, 1, if you add 3, it is 4. Similarly, 2, when you add 3, it is 5. So 3, when you add 3, it is 6. Goes on. So finally, 9, when you add 3, it is 12. 1, 1, 0, 0. So this is your input and the output table, step 1. Next, so your next step is to draw the state graph. Okay. So the state graph, let us assume that initially it is in the condition A. It is in the state A. So when it is in the state A, you have two inputs, right? Either it can be 0 or either it can be 1. So this gives at the time period T0. At the time period T0, your input can be either 0 or 1, 0 or 1, 0 or 1. Okay. So here you have to, if the input is 0, it goes to the next state B. If the input is 1, it goes to the next state C. So here the input is given by orange color and slash the next parameter is your output. Output is given by pink color. So at time period T0, see here carefully, when the input is 0, what is your output at T0? Output is equal to 1. Similarly, when the input is equal to 1, your output is equal to 0. Same applies in any of these conditions. If the input is equal to 0, the output is equal to 1. If the input is equal to 1, the output is equal to 0. That's why when the input is equal to 0, the output is equal to 1. When the input is equal to 1, the output is equal to 0. Just see this table and write down this output. Okay. So when it is in state B and C, again it has two inputs. Either the input can be 0 or 1. Similarly, from the C also the input can be 0 or 1. Okay. So when the input is from the B 0 or 1 and C 0 or 1, it goes to the state D, F, E, G. Okay. What is the reason why it is taken in this case is, let us see here, all this gives your input. Okay. 0, 0, T1, T0, 0, 0. Similarly, this also 0, 1, 1, 0, 1, 1. So 0, 0, since it is the first condition, you are taking it as D. 0, 1, that's why you are taking here as E. 1, 0, F. 1, 1, G. So this is why you are taking it in this manner. Okay. So let us consider the first instant when B is equal to, input is equal to 0 at time period T1. So when input is equal to 0, now these two will combine. You have A already here and 0. So 0, 0, when the input is equal to 0, what is your output at T1? You see here the output is equal to 1. That's the reason why you have output is equal to 1. When it is 0, 1, when T1 is 0 and 1. So it is 0, 1. What is your output? Output is equal to 0. So you have written output is equal to 0. For input 1, 0. 1, 0. What is your output at T1? You have to see only at time period T1 what is your output. It is 0. For 1, 1. Next is 1, 1. What is your output? It is equal to 1. That's why you have written here it as 1. Same thing applies for the other conditions also. For example, if it is 0, 1, your output is equal to 0. So it will be matching 0, 1, your output is equal to 0. So this is how you are writing the input and the output. Okay. Now moving on to the next case, again you have two options, either it can be 0 or 1, 0 or 1, 0 or 1, and G also can be either 0 or 1. This is at the time period T2. So T2, now you have to consider first, 3 bits together. LSB is the first bit which you have assumed. That's why you have got T0 first. Now you have reached T2. So see here in this condition, in this let us take D, E, F, G. So it will move on to the condition H, I is coming here. Why? What is the reason? So when you take from T2, T1 and T0, 0, 0, 0. Whereas in this case 0, 0, 1. That's why you have taken it as HI. Next J, 0, 1, 0. It goes like this. K, 0, 1, 1. Okay. So that's the reason why you have taken in this order. So H, I, J, K, L, M, N, P. Okay. So now let us see the first condition when D is equal to 0. What is happening? See here, the input is equal to now 0, 0, 0. So 0, T2 is 0, 0, 0. What is the output at time period T2? It is 0. So you have got it as 0. Now it is 0, 0, 1. Next one. So it is going to I, right? 0, 0, 1. What is your output at this instant? It is equal to 1. That's why you have got your output as 1. Next one, 0, 1, 0. So 0, 1, H, I, J, right? 0, 1, 0. What is your output for 0, 1, 0? It is equal to 1. T2 is equal to 1. So your output is equal to 1. Next case, 0, 1, 1. Okay, 0, 1, 1 is your input. What is your output here? It is 1. That's why it is 1. So similarly, you have to fill everything. Okay, so you have one more method to verify. See, when you calculate at any instant of time, if you take 0, 0, 0, 0, 0, 0 is your input. At the same time, what will be your output? 1, 1, 0, 1, 1, 0 or 0, 1, 1. So it will be matching. So you can cross verify it. For example, if it is 0, 1, 0. Okay. So where is your 0, 1, 0? 0, 1, 0 is your input. The output is 1, 0, 1. So 1, 0, 1. So this is how you have to proceed. So you have to complete D, E, F, G. Similarly, your H, I, J, K, L, M, P. So in the next case, you are going for the next T3 at instant of T3. Now here you have to listen here. All will not have 2 options. Why? Because your BCD input is only 0 to 9. So you have to see what are the options 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally you will be having only 9 options here. So H will take 0 and 1. Why? So your input here is 0, 0, 0, 0. Next it is I is 0, 0, 0, 1. Okay, so 0 is over, 1 is over. Now 2. 2 will be equal to 0, 0, 1, 0. 2. 3 is equal to 0, 0, 1, 1. Okay. 4, 0, 1, 0, 0. So here only your H and I will have 2 options, 0 and 1. All other remaining will take only one value. Okay, that is the specialty of your last instant T3. Same you have to proceed. How will you find the output? Same procedure. So let us take the first condition 0, 0, 0, 0. So the input is 0, 0, 0, 0. What is your output at T3? It is equal to 0. Similarly 0, 0, 0, 1. What is your output? It is equal to 0. So where is your I? 0, 0, 0, 1. What is your output? Is equal to 0. Or you can match here 0, 1, 0, 0. Whether it is getting 0, 1, 0, 0. So all the outputs and inputs will match together with that of your table. Okay, so this is a condition. Once it has achieved, it will go back to your reset state. Step 3 is to draw your state table. Whatever you have drawn in your state graph, you are going to replace it by your state table. So I'm taking the first column as at different instant of time T0, T1, T2, T3, and the second one is your input sequence. What you're assuming your LSB is first. Okay, and your next is your present state, next state, and your present output. So what will be your first table? Just if you want, you can see this state graph and you can fill it. So first state is, let us assume that it is in the reset state, that is at time t naught. What is your present state? It is A. It goes to the next state, that is B and C. When x is equal to 0, it is B. When x is equal to 1, it is C. That is what written here, when x is equal to 0 and when x is equal to 1. Now what will be your present output? Z. Z is equal to, when x is equal to 0, whatever you have here, you have to write. Output is equal to 1. When input is equal to 1, output is equal to 0. That is when x is equal to 1, output is equal to 0. Let us see the next state, that is at time t1. What is your present state? B and C. So what are your inputs? Either it will be 0 or 1. Okay. And what is your present state? B and C. Now what is your next state? D, F, E, G. That is what written here. D, when x is equal to 0, it is 0, 0. When x is equal to 0, E, it is 0, 1. When x is equal to 1, it is 1, 0 and 1, 1. So D, F, E, G. What is your output when x is equal to 0? What is your output you have got? When x is equal to 0, the output is equal to 1, 0. That is what written here. For C state, what is your output? 0, 1. 0, 1. It is written here. Okay. Now when at the time period T2, what are your inputs? You have 4 combination, right? 0, 0, 0, 1, 1, 0, 1, 1. So along with the T2, you are going to add your previous state or your present state. What are your present state? D, F, E, G or D, E, F, G. What is your next state? It is going to the next state, H, I, J, K. Okay, H, I, J, K, L, M, N, P. So what are your outputs here you have got? In the case of D, what is your output? 0 and 1. It is written here. In the case of E, what is your output? 1 and 0. It is written here. In the case of F, again it is 1 and 0. In the case of G, it is 1 and 0. So everything you have written here. Similarly, the last state, that is your T3. At time instant T3, you have 3 bits 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0 to 7. Okay, so what are the different state? H, I, J, K, L, M, N, P. So what is your next state? When x is equal to 0, you have the next state, everything is going back to your A. That's why you have got A. See here in this H and I, you have 2 options, when x is equal to 0 and when x is equal to 1. All other case, you have only the condition when x is equal to 0. That's why here you have the dash condition. Now for H, what is your output when x is equal to 0 and x is equal to 1? It is 0 and 1. It is filled here. For I, what is your output? 0 and 1. It is filled here. For all other cases, for J, what is your output? For instance, output is equal to 0. Similarly, you fill everything. For P, what is your output? Output is equal to 1. This is how you are going to form your state table. Now, your third step is over. The fourth step is your reduced table. So, how will you draw your reduced table from your state table? So you have to keep these two. Okay, so let me explain by using this state table. So this is your state table and this is your reduced table. Okay, so how will you reduce the state table? So by seeing this, you know that, so in first option you have output is equal to 1, 0, so it will remain the same. Okay, reduced state table, you are taking again T0, T1, T2, T3. You are going to see the rows which are similar. Okay, here there is no difference, so you have to write it as such. Present state A, next state B, C, 1, 0. At time instant T1, what are the states you have? B, C, D. Now see here you have 1, 0 and 0, 1. That is the output is the same. But when you see your diagram here, when you see your state graph BC, here you have input and output. If it is similar, you are going to reduce it. So in the case of next state, that is next state D, E, F, G, you can see here D, E, F, G, you are having the outputs to be similar, right? 1, 0, 1, 0, 1, 0. So instead of taking this 1, 0, with 3 separate states, I can take E, F, G as one single state. That's what it is done here. This can be easily understood by your state graph also. See here 0 in your D, it is input and output is 0, 0, 1, 1. But whereas in the case of F, E, G, Your input is 0, 1, 1, 0. Here also it is 0, 1, 1, 0. Here also it is 0, 1, 1, 0. So I can reduce this into a single state. So the state which I have selected here is E. That's why here in this case the state is reduced to D, E, E, E. That is F and G is eliminated and it is equivalent to that of E. Okay. So if I can write here F similar to E similar to G. Okay. That's why I have taken it as E. The output remains the same 1, 0, 0, 1. Now what happened in your time instant T2? T2, what is your present state? D and E. Instead of 4 states, you have reduced to 2 states. Now you see the next state. So in the case of the next state, H, I, J, K, L, M, N, P, see here the input and output here. So everything is going back to your A state. Output is also more or less similar, right? 0, 1, I is also 0, 1. Again it is everything is 0, everything is 1. So I can ultimately cut short it into H and so H is 0, 1, I is 0, 1, right? So all others you have the first output as 0. So ultimately I can write it as H is similar to I is similar to J is similar to K is similar to L. Okay. So H, I, J, K, L. So one of the output is similar. Here also it is similar. So I can cut short into one state. So I am taking it as H. Okay. So next option is M, N, P. Your output is again 1, 1, 1 and your input is A, A, A. So I can again cut short into 1. So M, N, P are similar. So I can take it as EM. So that is what is happening here. So in the case of reduced state, what you have taken, H and M is being taken instead of all other states. So the output will be remaining in as 0 and 1 and 1 and 0. See here, output is, where is the condition? Has. So the output will be remaining in 0 and 1 and 1 and 0. It remains the same. 0 and 1, 1 and 0. What about your third state T3? At T3 you are taking, you have already reduced it into H and M. The states is A and A. Okay. And when x is equal to 1, you are not getting, right? Because it is beyond 9. So what will be your output? It is 0, 1 and 1 dash. So here it is 0, 1. All I have made it into 1 and 1 and dash. That's what written here. 0, 1 and 1 and dash. This is how you have formed your reduced state table. So once your reduced state table is done, now you are going for your next, that is called as your assignment map. So how will you do your assignment map? So here now what are the states available? A, B, C, D, E, H, M and E. Okay. So now see the output carefully. So in the output you have 1, 0, 1, 0, 1, 0. Means you have A, B, here you have E and here you have M also is 1 and don't care. Okay. I can take it as don't care. So A, B, E and M are similar. 1, 0, 1, 0, 1, 0, 1 dash. So this has to be placed nearer to each other or adjacent to each other. So this is how we are placing it. So your assignment map, Q1, Q2, Q3, that is your present state. You are going to find out 0 to 7 will be your present state, right? Q1, Q2, Q3, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. You can write it in the other method also if it's applicable. Okay, I have written in this method. So we are going to write A, B, E and M adjacent to each other. So I can group this together. So this is adjacent, right? So A, B and M, E. That is the reason why it is written as, when you fold it, it will be adjacent to each other. Similarly, see here C, D and H. C is having 0, 1, D is having 0, 1 and H is having 0, 1. So these three has to be placed nearer. So C, D and H is also placed nearer to each other. So this is how you have to do your assignment map. So once this assignment map has to be done little bit carefully. Once your assignment map is done, you can go for your transition table. So what is your transition table, which gives you the present state, next state and your output, right? Q1, Q2, Q3. So what is your different states? A, B, C, D, E, H, M and the last one you don't have the condition, that this one is not present, right? That is 0, 0, 1. So 0, 0, 0, 1, you don't have the state. So what is your A state? A state is taken as 0, 0, 0. Just look it to the assignment and write here. B, what is the state? 1, 0, 0. C, 1, 0, 1. D, 1, 1, 1. H, 0, 1, 1. Right? 0, 1, 1. And M, 0, 1, 0. And E, 1, 1, 0. 1, 1, 0. Okay? So this is how. What will be your next state? Next state is equal to, when x is equal to 0, that is q1 plus, q2 plus and q3 plus. When x is equal to 0 and when x is equal to 1. So when your present state is equal to A, what is your next state? See here, when x is equal to 0, your state is B. Towards B, what is your 1, 0, 0? So write it here, 1, 0, 0. Similarly, when you have x is equal to 1, what is your state? It is moving on to your state C. So it is C is equivalent to 1, 0, 1. It is written here 1, 0, 1. Let us take the next state. At B, present state is B. Okay, so what is your next state? At x is equal to 0, your next state is equal to D. Right? D. So your next state is equal to, D is equal to 1, 1, 1. Similarly, when x is equal to 1, what is your next state? Next state is equal to E. E is equal to 1, 1, 0. So 1, 1, 0. Next, let us say take the next state, that is C. C, what is the next state? It is E. Both are E. Right? E is 1, 1, 0. So 1, 1, 0, 1, 1, 0. What happened in your state D? D, your next state is H. For both the cases, H is equal to 0, 1, 1. So 0, 1, 1, 0, 1, 1. When it is E, what is your next state? H and M. H is equal to 0, 1, 1. M is equal to 0, 1, 0. Okay. So H, similarly, you have to fill everything. For example, let us take the last condition M. When x is equal to 0, it is going to A. A is equal to 0, 0, 0. When x is equal to 1, there is no state. So you have to take it as don't care. Similarly, you fill the output also. When present state is A, what is your output? 1, 0. So you have to fill all the output as such. Okay. So now let us do the next step, that is building the K-map. So your K-map you are going to do for the next state, Q1 plus, Q2 plus, Q3 plus and Z. So 4 K-maps depending on what are the inputs, X, Q1, Q2, Q3, present inputs, X, Q1, Q2, Q3. Okay. So let us consider the first case. So here also you will be getting Q3 plus, Q2 plus, Q1 plus. Okay. Here also Q3 plus, Q2 plus and Q1 plus. Okay. So let us fill the K-map. For example, 0, 0, 0, 0, what is your value? It is equal to 1, 1. 0, 0, 0, 1. So 0, 0, 0, 1, right? Here it is. So what is your value? It is equal to don't care. That's why you have got here don't care. Next, let me consider 0, 1, 0, 0. So x is equal to 0, 1, 0, 0. So 0, 1, 0, 0. What is your Q1 is equal to 1. Similarly, you have to fill all the different values. Okay. So let me take the next condition. For example, let me take 1, 1, 0, 0. Okay. X is equal to 1. First is X. Q1, Q2, Q3 is 1, 1, 0, 0. So 1, 0, 0. So 1, 1, 0, 0. What is your value of Q1? It is equal to 1. That's why you have got 1. For example, 1, 0, 0, 1. So x is equal to 1, 0, 0, 1. Here it is. So it is don't care. Okay. So this is how you have to fill for Q1. Next you have to, so you have got the equation D1 is equal to Q1 plus is equal to Q2 dash. Similarly, you have to do it for Q2 plus, Q3 plus and Q4. It's not Q4, it is Z for your output. So once you do it for your output, so Z is equal to Q3 dash X dash plus Q3X. Now you are going to, once you have got all the data, you are going to construct a code converter circuit. So how will your code converter circuit look like? So give the 3 flip-flops, flip-flop 1, 2 and 3, flip-flop 2, flip-flop 3. You are using D flip-flops. Okay. Now you have the input D1, D2, D3. So D1, what is your value? You have got Q2 dash, D2 is Q1, D3 you had an expression, right? So what is your expression? Q1, Q2, Q3 plus Q1, Q3 dash, X dash plus Q1 dash, Q2 dash and X. So here you can go for AND gate and OR gate. The same equivalent representation they have represented it by NAND gate. So this will also give, finally it will be giving an OR expression when you apply De Morgan's theorem. Okay. Similarly, in the case of your Z, what is happening? Z is equal to Q3 dash X dash plus Q3 X. Q3 X plus Q dash, Q3 dash X dash. So here also, instead of going for AND gate and OR gate, they have equivalent representation using NAND gate they have used. Okay. So this is how you will be getting your code converter circuit, that is BCD to XS3 code.